a quick recap of what we did so far is we used this rule or this tautology rule and simplified these two. We obtained A implies C and this. Then we applied this tautology rule and we were able to simplify this as well. Subsequently, we got this. Now, we know that P and P implies Q is a tautology, which means this one is P. So therefore, you can use this rule, P and P implies Q is Q. So we get this. That's precisely what we wanted. So therefore, the given claim is true. So the idea is this. Given an argument involving natural language or any natural language like English, so what we do is the following. We first model using proportional variables. So we abstract the essence out of this, then bring this. There are a couple of ways of doing this. One approach is simplify using well-known equivalences implications. That's precisely what we have done. And when you know that this implies this is a tautology and the argument is given, so premise is given to you, which means it is true. So the premise is given to us, which means it is true, and in a context this appears. This being tautology, one can always replace this with this. Okay? You can look at it this way. Pay attention. In a context, this appears. Let this be X. And we know that X implies Y is a tautology. X appears in a context, which means this one is true, and X implies Y is a tautology. What does that mean? For all possible values of this and this, the expression is evaluated to true. So X appears, it is true. X implies Y is true, therefore Y will also be true, which is why you replace this with an equivalent one, meaning you replace this with Y because X implies Y is a tautology. And if you reason out, X appears, so it is true, and we know that X implies Y is a tautology, therefore Y has to be true, so you can always replace that with Y. So that's precisely what we have done at each of this place. Here is one rule using which we have simplified, and then we have used contrapositive to simplify further. Then we have used this P and P implies Q, that rule to simplify further. This is one approach. One can always work with the given expression directly, meaning A implies B and B implies C and negation C imply this. You can, without using all of this, one can always simplify. How do you do it? Use truth tables. Use truth table method. But the problem is it will be a bit lengthy because there are 3 variables. So you have to look at all possible values for the variables A, B, C. With respect to each of them, you need to calculate A implies B, B implies C and negation C. Check whether that implies negation A is a tautology or not. It's correct, it will work fine. So the reason is, if an expression involves many variables, following truth table approach is bit tedious. Although it works, it is a bit tedious. to simplify that part meaning to simplify this approach. So what we do, can we simplify the given premise itself, given argument itself, using well-known implications and equivalence. That's precisely what we have done for this case study.